In this recording, we're going to learn how to solve linear systems by a new technique called substitution. We've learned how to solve things graphically, but this will confirm our graphical solutions, and in some cases, if the answer is not an easy number to identify on a grid, it's going to be more accurate. So let's start out by checking. Let's start out by demonstrating that this solution, this point, checks in this system. So go ahead and play the recording after you've made the substitutions and checked. So hopefully you did that substituting. Okay, so that point clearly is a solution to the system. Now before we go any further, I'd like to consider this situation. If you grew up in this culture, you're very comfortable with these two representations, a dollar and 4 quarters. We know they're equal, right? Just because we grew up in this culture. They don't look anything alike, though. I mean, look how different they are. This one's kind of rectangular and green and paperish, and these are 4 of them, and they're small and metallic, circular. But we just know that if I give you $1 and you give me 4 quarters, we're even, right? And they each have their own use. You can think of situations where you'd rather have a dollar bill or you'd rather have the quarters. So that change of money is called a substitution. Well, we can do that here. We can make a substitution of x minus 3 in place of y because of that equal sign. Because it says that they're equivalent, I can make a substitution. So when I write that first equation, I'm going to write out 2x, but when I get to the y, I'm going to, instead of y, write x minus 3, and I'll use a color to demonstrate that. I'll use green. And then I've got my equals 9. So that equation, that top equation, got substituted. In place of the y, it got something that's equal to it, which is this x minus 3. Sometimes I like to draw a little box around it and draw an arrow to where it's going. It's going in place of that y because it's equal. Now it's saying, okay, substitute in your point for 1 and show it still works. Please do that. Okay, so hopefully you took time to do that. Well, there is no 1 to sub in, but I got my 4's substituted in, right? Still checks. And now part B over here says, this really should be part B, and this should be part C, right? So it says solve the system by finishing the substitution from part B. In other words, take this equation that we've got, this green and red equation, and then go ahead and proceed to solve it out. So here's the good news. Because it's an equation with just one variable, not 2 variables like we had before, we can solve this pretty easily, right? So let's solve this for x. Play the recording when you're ready. Okay, so hopefully you did so I can combine like terms in the left side. I can add 3 to both sides. I can divide by 3. So x equals 4. Well, that's good news. I thought it was going to be 4. But that's not the answer to the question, because the question was an x and y coordinate. So now I really just need to pick either one of these equations, whichever I find to be easier. I'm going to use the bottom one. And in place of x, I can substitute 4. So I did solve the system, and its x is 4 and its y is 1, so I can write it as a 0.41. Okay, so that's the gist of our substitution. There are steps written at the bottom of the page. You can refer to those. Let's dive in and see if we can solve this example 1. Okay? So we're going to solve it by the substitution method. First thing we're looking for is there a variable that's already solved for itself? And there is. This y is equal to x minus 4. So therefore, I can box this in. This is like my dollar here. And I can substitute it in place of the 4 quarters. Okay, so this looks different than a y, but because of the equal sign, I know they're equivalent. So I can write it out. And again, I will use a color just to really make that point, that I'm substituting in place of y something that looks different than it, but is equal. Okay, now I need to proceed to solve this out. So go ahead and solve that for x. Play the recording when you're ready. Okay, so hopefully you paused and worked that out. It's the only way to learn is to try it. Try it on your own. Okay, so I think I've got the x coordinate, but I need to find the y, right? I can pick either one of these equations. I like the top. It looks a little easier. It's already solved for y. So I'll write out that equation. And now I will make a substitution of x, 6 in place of x, right? So it looks like y is going to be 2. So when I write the equation, when I write the solution, and this is a common mistake, I need to make sure I'm writing the x and the y, both points. So the solution is 6, 2, all right? And maybe it's not an x and a y in every equation, but there's going to be 2 unknowns that we solved for, right? 2 letters. So there were a lot of decisions I made along the way here in the process of solving, a lot of moves I made. It's possible that I made a mistake. So I need to confirm that I got the right answer. So what we're going to do over in this space is check in both equations. So I'll write out my both equations side by side here. Now I'm just going to make substitutions of my point into my equations to make sure that it checks. So why don't you make those substitutions, then play the recording when you're ready. Okay, so hopefully you paused and worked this out. Excellent. Let's try one that's a little more complicated. Let's jump ahead to number 3. So in number 3, I need to look first to, basically I want to make the work as easy as possible for myself, right? So I'm looking at these 2 equations and I'm trying to find one equation that I can get into this form, x equals or y equals, because then I can make a substitution. So this first equation does not look super easy to get in either of those forms. I could do it, but it would take some work. The bottom equation seems a little easier because there's a coefficient of 1. So I already just have the 1x. I just need to get rid of that 4y. So let's do that. Let's add 4y to both sides. And so I've transformed this bottom equation to be x equals 4y minus 1. So let's make a substitution in this case. We're going to take this top equation, and I'm going to use red. If you have some colors handy at home, go ahead and use them to color code stuff. And when I get to the x, though, this is where I substitute my 4/4 for $1, right? I've got something that does not look like x, but it's equal to x because that equal sign. So in place of where I said 2x, I can make a substitution, 4y minus 1. I'll come back to my red pen. I got to write the rest of the equation. Plus 2y equals 3. Okay, so I've got this top equation written out, except you don't see any x's anymore. I've made a substitution of something equivalent to x. Now we're home free. We just need to solve this equation in one variable. Go ahead and do that and play the recording when you're ready. Okay, so go ahead and distribute here, right? Because we have a number outside of the parentheses. We want to undo the parentheses. Now we're looking at combine like terms on the left side. We'll add 2 to both sides. And when we divide by 10, I know some of you are thinking, oh, y is 2. But it's not, right? 5 cookies divided 10 ways. You don't each get 2 cookies, you get half a cookie, right? So we're almost there. We need to find out now what the x is. I can go back to any of my previous equations that relate x and y. And I happen to see a handy one right here, right, that already has x equals. So that's going to make it nice for me to find out what the x is. So I can go x equals 4y minus 1. But now I can make a substitution. In place of this y, I can make a substitution of something equal to y because of that equal sign. So x equals 4 times half minus 1. So let's do some mental math here. Half of 4, well, that's 2. 2 minus 1, well, that's 1. So here I've found out my x and my y. I just need to write them in the proper order. We always put our x first. We think that is the solution. We just need to do a check. So go ahead over into this space and check your solution point in both equations, both original equations, because you may have made a mistake, or I may have made a mistake, going from this form that we were given to this manipulated form, and I won't catch that mistake unless I check in my original equation. Okay, so do it on your own. Play the recording to check. Okay, so making those substitutions. And there it is. It checked. Thanks for watching.